Okay, I think we can start. First of all, good morning, everybody, and thank you for attending today's webinar. The purpose of this presentation is to help us understanding acoustic performances and why it's imperative in today's life to give benefits where and when required. Now move on to Jan. Just a few information about the speaker of today. So Jan Skiers is now a sales and market development manager for Middle East. He's a Belgian guy. He started working after his bachelor in marketing in DuPont, giant of American chemical company. And the first 13 years he worked for paint in different functions. And starting 1999, he moved on glass market. Even here he had many roles. So it was a technical service, product development, marketing, and sales. Since 2013, after Kuraray took over GRS, which was a department of DuPont for glass laminating business, he moved on Kuraray, and actually, as I said, is our marketing, sales and market development manager for Middle East. Now, let me give you just a few words about the etiquette. The purpose, regarding the etiquette, we're just some quick housekeeping. Your audio and visual has been turned off to aid the quality of this presentation. There is a facility for you to raise questions at the bottom of your screen where there are a variety of icons. The one shaped like a speech bubbles enable you to post comments. So if we have a time, we will go through some of these at the end. Otherwise, we will reply to each one individually afterwards. We will also record this presentation for those unable to attend or for those that require a copy. Because this is a live presentation, I apologize in advance for any technical issues, touch woods, we have been okay so far. Okay, now let's move the presentation to Jan and enjoy the presentation.
Yes, good morning, good afternoon, everybody around the world. As Sandra said, the main topic of this seminar is acoustic properties and how we as a company can help you in achieve a better acoustic performance in your building or your project. Just a few words about our company. Kuraray might be a name that you're not really familiar with, but Kuraray is a Japanese chemical company, multinational chemical company with a lot of different products, and I'm sure in your life you have been across a product of Kuraray already, because many of these products are quite unique. And for instance, PVA film in every screen, telephone, laptop, TV screen, there is a PVA film for optical use. I'm sure also the water-soluble PVA film, which is used in detergent for washing machines and dishwashers. I'm sure you've already seen as well. Many of your clothes are treated with PVA as well, the cotton. So I'm sure you've come across one or more products of Kuraray in your life already. We as a PVB division, we are part of the vinyl acetate business of Kuraray. So we as a company, we as a business unit, we produce PVB and Sentry Glass and some other products. Just on the next slide, I will explain a bit more what Trozifol is doing. So Trozifol is the brand name for the PVB business. We are a leading global specialist in development, manufacturing, and supply of PVB films, and Ionoplast interlayer, which is the generic name for Sentry Glass. We have laminated safety glass applications in architectural, automotive, marine, and aerospace business. The offering is divided in between, as I said before, Trozifol PVB, which is the brand name of our PVB products, and Sentry Glass, which is the brand name of our Ionoplast interlayers. We as a company, we provide you possibility to have innovative glass laminating solutions. We offer you structural and functional interlayers for safety and security applications. Also for sound insulation, which is the main topic of this presentation. We also have products that can help you in decorative applications like colored interlayers, digitally printable films, and other innovative products for interior design projects. We also have a brand of a range of products that can help you in UV protection. Either on one side, block 100% the UV to protect fabrics or artworks inside the building. On the other part of the spectrum, we can also offer you products that let UV through for botanical gardens or greenhouses. And just to mention, I will come to this later on, our Trozifol PVB ultra clear film is the lowest yellow index PVB film in the industry. This is where we are located. We have a global outreach. We have 7 manufacturing sites across the world. We have 5 R&D laboratories, and we have about 18 sales offices across the world. The business in Europe and Middle East is mainly run from Germany. So production is in Germany, main office is in Germany. And I'm located in Dubai, so I handle the Middle East from the Dubai office. So what is sound? Going to the main topic of this presentation. What is sound? In physics, sound is a mechanical wave that propagates through a transmission medium such as gas, liquids, or solids. In human psychology, sound is the reception of sound waves and their perception by the brain, which can be different from person to person. Then moving on to noise, because sound is sound, but for some types of sound, sound can also be perceived as noise. So noise is an unwanted sound. The perception of noise varies from person to person. I mean, some people might think of a specific song as a nice sound. Others might think it's just bloody noise. Sound may be acceptable in one circumstance, but not in the other. I mean, loud music can be nice in a pub or in a disco, but it can be very annoying when you're trying to concentrate on a specific task. A music CD is called sound when it's played by the occupant of a house, but it's considered noise when it's being played loudly at 2 o'clock in the morning by the neighbors. So going a bit more into the details and the theory of the sound. Since sound is a wave, we can relate the properties of sound to that of a wave. The basic properties of sounds are the amplitude, which is the size of the wave or the height of the wave, which is called loudness. The frequency in hertz, the pitch, so the numbers of cycles per second, meaning from left to right when there is a full cycle made from baseline to baseline. This is the frequency. And then the wavelength is the regularity. So the wavelength and frequency are inversely proportional. So double the wavelength and the frequency is half. A bit more on the characteristics of the sound wave. The wavelength, as I said, is the length of a full cycle of a wave from one point to the next same point. So as you can see, from baseline to baseline, from the left side to where it says number 1 is the typical wavelength. We measure it in meters, the wavelength, and the symbol for the wavelength is a symbol lambda. The amplitude of the wave is like the size of the wave. We need to remember it goes from the baseline up to the top of the curve, and not from top to bottom of the curve. The frequency is the number of complete waves to pass every point, to pass a point in every second, and it's given in the unit of hertz. So as an example, this would be if 10 waves pass in 2 seconds, the frequency would be 5 hertz. So as you see also in the graph here on the top, we have 1, 2, 3 in 1 second. So in this case, in this example, it is 3 hertz. Then we can also say that the human ear is active between 20 hertz and 20 kilohertz. You can see there's a lot of examples here on different animals and the frequency they are able to hear. So humans are, compared to some animals, quite restricted in their frequency level that we can hear. So anything below the human threshold of 20 hertz is called infrasonic. Anything above 20 kilohertz is called ultrasonic. Moving on to sound pressure. Decibel or sound pressure level is a widely used unit of sound measurements, indicating how loud something seems relative to the threshold of the human hearing. An increase in 3 decibels is perceived as double the sound pressure level. So some examples of sounds. The human speech in general is around 60 dB. Loud rock music is around 110 dB. And just for your information, the loudest sound threshold you can hear without damage to your ears is about 120 decibel. This is the complicated formula how dB is calculated. I will give you some details on some aspects of this formula. So intensity is part of the equation. As it relates to sound, the intensity is defined as the power carried by a sound wave per unit of area, and it is expressed in watts per square meter. The power is defined as an energy per unit time measured in watts. Watts are used to measure the output of power of amplifiers and the power handling levels of loudspeakers, for instance. The pressure is defined as a force divided by the area over which it is distributed, measured in newtons per square meter, or more simply in pascals. So in relation to sound, we speak specifically of air pressure amplitude and measured in pascals. So here on this slide, you can see the formula how decibels is calculated. The objective measures of intensity and air pressure amplitude relate to our subjective experience of the loudness of the sound. In general, the greater the intensity of pressure created by the sound waves, the louder the sound is perceived by us. However, loudness can be measured only by subjective experience, that is, by an individual saying how loud the sound seems to him or her. The relationship between air pressure amplitude and loudness is not linear, so that means that in the examples given, 1 decibel is not noticeably practical. A difference of 3 decibel is just perceptible, 5 represents a clear difference, and 10 is sensed as doubling or halving the sound. As an example, a conversation at 60 decibel, if the conversation was supposed to be 63 decibel, it would have double the sound pressure level of the original conversation. If the conversation rose to 66 decibel, then it would be 4 times the sound pressure level of the original conversation. And if it rose from 60 to 70 decibel, then it would actually mean that the sound pressure level is increased by tenfold. So to simplify this, we need to include some weighted factors, and we will touch on this in a couple of slides later. So what are the effects of sound on buildings is, of course, what we want to know in this presentation. Noise transmission through a glass facade. We are mostly worried about the acoustic performance of the facade, of course. And noise is coming from the external environment, so direct airborne transmission. but also noise can be coming from adjacent rooms, meaning next door or on top or on bottom, so vertical and horizontal flanker we call it. In order to achieve acceptable internal noise levels, we must need to achieve a certain acoustic insulation performance on the facade and on the walls between the different rooms. This performance is typically specified by acoustic engineers or acoustic consultants. So in the specific case of noise transmission through glazed partitions, which is quite a big part of our industry, I have to say. So the level of sound insulation performance needed varies depending on many factors, including project requirements, client specifics, and employee well-being. The performance may be specified using either a laboratory value, RW, or a value measured on site, which is called D value. In order to achieve unintelligible speech from another office, the minimum sound insulation between two offices needs to be approximate 38 dB. When you really need to have total privacy, it's important that the minimum sound insulation should be about 48 dB. It is key to understand the level of noise relative to the location of the building. This could be influenced by a nearby road, a motorway, a busy pedestrian retail area like a shopping mall, a school, a railway, an airport, the flight path of airplanes leaving from that airport. So various sound metering devices can help plot a 3D spectrogram of the area, showing certain parts of the building subject to noise more than other parts of the building. Considerations, of course, healthcare, these kind of places may require a high level of sound insulation. Other places might require a less intense sound insulation level. So how do you measure sound and sound differences? So the basic method is to create a uniform sound in one room and measure the sound in that room, and then in the second room you measure the sound which is coming through your specimen or your glazing partition. The construction of these acoustic rooms where the certified testings are done carefully to minimize flanking transmission of the noise. So the standard test is 1 meter at 250 centimeters by 1.5 meters of the panel what you test for the acoustic performance. In some laboratories, there's also the possibility to do a full size measurement of the sound performance of the panel. In the UK, for instance, you can have a test run from 4 up to 3 meters. Understanding the acoustic reading. So there is a lot of abbreviations when defining the characteristics of airborne sounds, and there's a few mentioned here on this page. So SRI, the sound reduction index, it is expressed as a spectrum of frequencies. However, the most practical purposes, it's better to use a single number rating. RW is the weighted response to the ability of the human ear. Then C, for instance, is the correction factor for the medium to high frequency levels in response to the ability of the human ear. The correction factor just limits to the medium and high frequency ranges, considering living activities like railway traffic at medium and high speed, road traffic above 80 kilometers per hour, jet aircraft at short distance, and for instance, factories emitting medium to high frequency noises. CTR is where the TR stands for traffic, is the correction formula for medium to low frequency in response to the ability of the human ear. And this is mainly railway traffic at low speeds, urban road traffic, propeller-driven aircrafts, disco music, factories emitting low or medium frequency noises. So the acoustic properties of glass can be improved in several ways. The most easy and the simple way is make the glass just thicker. So the greater the mass of the glass, the better the acoustic performance. What you can also do is use 2 layers of glass with an air gap in between. This is a combination then of more mass and a decoupling of the sound. Very large air gaps are the best. The bigger the air gap, the better the acoustic performance. And the relative thickness of the panes is a factor because of the potential resonance issues of the glasses. And of course, what we suggest and which is beneficial for all of us is the incorporation of a PVB film or an acoustic PVB film to dampen the sound within the glass. Just a short section to explain what is laminated safety glass. I mean, I'm aware that most of you people are glass experts, so you're considering this as a given, but just for the people who are not really familiar with laminated glass, we would just want to explain you quickly what it consists of. So a laminated safety glass is a sandwich of 2 or more layers of glass with an interlayer in between. It can be a PVB film, a Sentry glass film, or any other laminated glass film. What it does, the PVB film or the ionomer film, is that it ensures that in cases of glass breakage, the particles of the glass stick to the interlayer, so it becomes a safety glass. And a certain impact can be absorbed also by the laminated safety glass, which I will show you in the small video attached here. So as you can see, this is a impact testing according to the European norm. A metal ball of 4 kgs will be dropped on the glass itself. As you can see, the glass is impacted, it is breaking. There are some small particles of the glass detached from the laminate, but in general, it's considered a safety glass because the majority of the particles are still sticking to the glass, and the ball itself or the projectile is not passing through the glass. We as a company, we have the broadest portfolio in the industry to fit your glazing needs. What we have in our portfolio is Trozifol Clear and Ultra Clear, which is our standard PVB product. We have PVB products for decorative glazing, our colors, and specifically our black and white total opaque PVB. Important for this presentation, of course, the Trozifol sound control films, which is a monolayer acoustic film and a multi-layer acoustic film. I will explain more in detail later in a few slides. We offer films for security and structural performance, Sentry glass natural UV, which is typically used for botanical gardens because it lets the natural UV light through the interlayer. Sentry glass extra is our latest new development in the Sentry glass range. We have a translucent white Sentry glass, and we also have a Trozifol extra stiff, which is a structural PVB. For specialized applications, we have specialized films. Trozifol HR is a typical film used in non-autoclave lamination. We have Trozifol UV Extra Protect, which is, as I mentioned before, 100% blocking all UV radiation in the total spectrum of UV. We have Trozifol Natural UV, which is giving you similar performance to Sentry glass Natural UV. So basically products being used in greenhouses and botanical gardens. Trozifol XT is our Hurricane PVB. we have, as we mentioned before, Centric Glass Natural UV, and then Spall Shield is a hard-coated PET, which is used in bullet-resistant glazing and train windshields. Auto transportation, we have a range of products which are used in the automotive industry and in the transportation industry. We have our clear product, we have a shade band PVB, we have color PVB. Spall Shield, as I mentioned, is used in transportation industry as well. Centric Glass as well. Acoustic films is also a big part of the automotive business. And we have Wedge, which is a product that is used for a head-up display. Then we also have a recycled product, which is 100% recycled, Butazide G. Now more in detail about our acoustic PVBs. So we have Trozifol SC monolayer, which is our single layer acoustic product, and we have Trozifol SC multilayer, which is a 3-layer acoustic product. As you can see in this slide, comparing both products a bit, on the left side you have the Trozifol monolayer. So it's a homogeneous, little softer sound damping PVB. It has outstanding sound protection properties, and it's been used since about the year 2000. On the right-hand side, we have our Trozifol multilayer. So this is a soft sound damping PVB layer in the middle, which is encapsulated in standard PVB. So you have two standard PVBs on the outside and a sound damping PVB in the middle. It is a extremely high production efficiency because it handles like regular PVB. It doesn't, the monolayer is a bit more sticky because of its softness. The multilayer is actually performing exactly the same as a standard PVB in terms of production efficiency. And it also passes the EN 356 and EN 12600 impact performance test like the regular PVB. So a bit more on what our sound control PVBs are doing. It's giving you outstanding sound protection properties. It is a significant reduction of noise compared to standard glazing solutions. We have certificates of product that have been tested, combinations up to 52 decibel reduction. There is an improved sound insulation, values up to 3 dB compared to glass with standard PVB. Outstanding properties in terms of safety, long-term stability, light fastness, and optics. Acoustic laminated safety glass interlayer reduces noise up to 5 decibels higher compared to a single glass sheet. And we are the world's only PVB interlayer manufacturer to have Trozifol monolayer and Trozifol multilayer in our portfolio. Comparing standard PVB versus the two acoustic products. In terms of acoustic performance, of course, regular PVB also has a certain acoustic performance, but it is less than the acoustic products, the multilayer and the monolayer. In terms of optics, all products are great in terms of optical performance. The multilayer, however, in automotive applications, it's sometimes considered to be, because of the 3 layers, there is an interference, a light interference, and it could be that there is a certain risk for some orange peel. The combination with other PVB films, of course, standard PVB can be combined with color PVB. The multilayer, as the outside 2 layers of the product are also standard PVB, can also be combined with color PVB. The monolayer, however, can only be used as a single layer. It cannot be combined with color PVB. In terms of impact performance, the standard PVB and the multilayer have the P2A performance according to EN 356. The monolayer, being that it's a more soft interlayer, has a slightly lower impact performance than the other 2 products. In terms of yellowness index, we have the lowest yellowness index in the market, so it is very clear for ultra clear product, which is our lowest YID product. And then for multilayer and monolayer, it's also very low in YID. So coincidence dip, what is it? The frequency at which the glass panel vibrates in unison with the frequency of the incident sound pressure waves. So when the adjoining materials resonate at the same speed, causing the sound to flow easily between them. Different thicknesses of glass resonate at different frequencies. And an acoustic interlayer extremely helps you in terms to dampen this effect. So the coincidence effect is much less when you're using acoustic PVB. This is illustrated in the next slide. So you see here this coincidence dip at the range of, we're talking here 10 mm glass. So if you look on the equation before, the frequency 12,500 divided by the thickness of the glass. So in the case of 10 mm glass, this is in the range of 1250 Hertz, which is right about where the dip is. So the monolithic glass and the standard PVB has a dip in this frequency range caused by the coincidence, and the acoustic PVB is totally compensating this dip. So in the range of this dip, there is about 10 dB difference improvement of sound performance when you use an acoustic PVB compared to regular PVB or a monolithic glass. So how can I achieve noise insulation with monolithic glass? You can increase the mass of the glass, so more glass means better sound performance. You can use a standard laminated glass, which give you also a better performance. And then the optimum sound insulation is the use of a laminated glass with acoustic PVB. So you see here an example of 10 millimeter monolithic glass is giving you a sound reduction RW value of 33 decibels. If you use a laminated glass with standard PVB using 5+5 millimeter glass, so the total glass thickness is the same as the monolithic glass, and you use a 0.76 standard PVB, then your acoustic performance is already better and you can achieve 35 decibels. If you use the same glass thickness with the acoustic PVB, so also 2 times 5 millimeter glass and a 0.76 acoustic PVB, the RW value is already increased to 38 dB. So the option you have then is to keep it at 5+5 to have the same thickness as the original monolithic, or you can reduce the glass thickness and even have a better performance than the original 10 mm glass, as in this example, reduce the glass thickness from 5 to 3 mm. This is an extract from some of the testing we have done. A lot of combinations are available on our website in our acoustic calculation tool. This is just a couple of examples of the levels of acoustic performance you can achieve by various combinations of laminated glass, IG units, or triple IGUs. Another example, if you use 8 millimeter float glass, you will reach 32 dBs RW. If you use the same thickness of glass 4+4 with a PVB, you can already reach 34 dB, which is already an increase of 2 decibels. If you use the same thickness of glass with an acoustic monolayer, then you increase it again with another 3 dB. And on the right-hand side, an example of an IGU. So 4+4 with 0.76 PVB, a 16 millimeter airspace, and another 4 millimeter glass gives you a 37 dB. And if you use the same combination with an acoustic PVB, you reach 39 dB. So how can I achieve noise insulation, reduce the weight of the construction, and save cost? So an IG unit, typically with an airspace of 6 mm glass of 4+4, laminated glass with normal PVB, in this case gives you 38 dB reduction. If you do it with an acoustic PVB, same combination, you will end up at 41 dB. So reducing the glass thickness, which will save you costs, can even achieve a higher level of reduction compared to the original standard PVB. So on the right hand side, we just gave you all the interlays we have in our product portfolio and the relative sound performance reduction that they can achieve in a 5+5 millimeter standard laminated glass. So you can see annealed glass 10 millimeter in this case is then 33. Sentry glass and Trozerval extra stiff, which are structural interlays, give you also a small increase in sound performance, but it's not the same as standard PVB and acoustic PVB, of course, because given the fact that these are structural interlayers, you need to have a certain stiffness in the interlayer to have a structural performance, which is, of course, not beneficial for sound damping. So the rule of thumb is if you go from a monolithic to a laminate with acoustic PVB, you can achieve 4 to 5 dBs extra performance. So this is just an estimation guideline summary comparing a monolithic 8 mm versus a laminate 442 with our different interlayers, and then a 10 mm, a 12 mm, and a 16 mm. So you can see, for instance, 16 mm, a normal 16 mm monolithic glass gives you 36 RW value. If you use the same with the acoustic product, you already have 41 dB. So the rules of thumb are simple. Doubling the mass of the glass will give you about 3 dB extra performance. If you go from monolithic to a structural interlayer, it's basically more or less the same. You might gain 1 or 2 dBs. But given the fact, as I mentioned before, it's a structural stiff interlayer, it doesn't really give you a very good acoustic performance. Going from monolithic to standard PVB laminate is giving you a better performance. Going from monolithic to the acoustic PVB product is giving you 4 to 5 dBs better performance. And going from a standard PVB to an acoustic PVB is roughly 3 dBs better performance. If you increase the PVB thickness, because this is like a story that's sometimes going around in the industry, if you increase the PVB thickness, you have a better performance. Well, we know from testing that if you use a 0.76 acoustic interlayer or 1.52 millimeter acoustic interlayer, the acoustic performance is exactly the same. Another story which is being told many times is that if you use asymmetric glass, let's say a 6 mm and an 8 mm, that it gives you a better acoustic performance. We know from testing and based on the testing we have done that this is actually not the case. Unwanted noise in urban environment is an increasing issue. The UN predict that 68% of the world's population will be living in cities by 2050. A 2015 US census stated that 62% of US citizens resides in cities, contributing to only 3.5% of the landmass. In 2008, for instance, there were just under 1 billion vehicles on the roads. In 2015, it was already 1.3 billion. And the forecast for the next 5 years is that there will be 2 billion vehicles on the road, which is causing, of course, a lot of noise pollution. So population in our cities is a challenge for architecture, for planning, and for infrastructure. For average noise exposure, the World Health Organization strongly recommends reducing the noise to these levels of 53 dB maximum. So this is a combined level of the day, the evening, and the night, called LDN. And this could be achieved reaching a maximum 53 dB by using electrical vehicles mainly, introduction of urban soundscapes, and reducing and banning of vehicles in the cities. The architectural design will all have an impact and hopefully contribute to the reduction of the sound level in our cities. This is a study that has been done in the UK, in the London area, where all the roads were mapped in terms of sound and the level of sound that is created by these roads. You can see different colors having different dB levels. As you can see on the left-hand map, there is a lot of streets in a highly dense city like London, where the sound level is reaching more than 75 dBs. So in this graph, you can see the level of noise that people are exposed to. Same, it's an average of the day, evening, and night. So the level from 0 to 55 dB is 61% of the population. This is also London area, by the way. So this means that 40% of the population were subjected to noise level in excess of 55 dBs, which is well above the recommendation of the WHO. Noise pollution is a growing concern, not just in the UK, but also in Europe and the rest of the world. So there are many studies that have been performed to map the noise pollution. Europe, for instance, undertook studies also in 2017, which gave similar results that were found in the study that was done in the UK in the London area. The WHO carried out further studies, and the evidence proved that there's an increased link between noise and certain types of illnesses. The cost to the economy, this is also UK-based figure. So the cost to the economy from sleep deprivation alone is in the excess of £40 billion a year. So the calculation tools we can help you with on our website. We have structural calculation tools. We have visual calculation tools for transmission, light transmission, and U values and that sort of stuff. But the main one I want to point out today is a Troziful Sound Lab app, which is a database for determining the sound insulation values for your glass compositions. And this is based on a database we have of the total tested combinations of laminated glass and IG units. We are working currently on an improved sound calculator, which will give you even better performance than this one. But this is already a very good tool where you can select and try to figure out which combination you need for a certain dB level. These are the examples of what you can get out of this database. So you can have the total number, the RW value, all the statistics. You can also have a graph coming out of this tool with all the details at a certain, at the specific levels of sound at a certain frequency. So it's an extensive database, and you will find it most interesting. Some references of a project where our acoustic PVBs have been used. This is 19 Elms in London. It's a 19 floors of hotel space with additional 25 floors of residential apartments. So 56 floors in total. And acoustic monolayer PVB has been used in this product. In this project, I have to say. The Stadthalle in Troisdorf, in our hometown of our PVB production. Also in this case, acoustic monolayer PVB has been used. It's a multifunctional hall and it offers space for about 1,000 people. And the acoustic performance, protecting it from the road just next to the building, was very important in this case. The Pier House in Brooklyn, New York, in the US. It's a multiple story building, also 193 room hotel, and in this case also acoustic monolayer has been used. Sky Tower in Wrocław in Poland, office space building with more than 30,500 square meters of office space, commercial space, art galleries, pubs, restaurants, service outlets, in total 25,000 square meter. Recreational part of the building includes an entertainment center, a spa, and a sports and a medical center. Also, this entire facade has been built using monolayer acoustic PVB. This is another project in the UK, in London, with Fosters and Partners. It's a mixed-use development, 3 landmark towers along the Albert Embankment and the south bank of the River Thames. It's just opposite the House of Parliament, 15 to 27 stories, and it provides 253 apartments. Again, acoustic monolayer has been used in this project. So how can we as a company support you in the design of your acoustic laminated glass? We have consultancy services, which is not helping you only on the calculation of acoustics, but also in the calculation of structural windows and structural elements. We can also offer you a calculation tool for bomb blast performance. As I mentioned before, thermal and energy performance is another calculation tool we have on our website. We did some testing design, of course, for hurricane glazing in the US, where Centriglass is a product that has been developed specifically for hurricane glazing. We have our laminated glass expertise. We have technical people, we have marketing people. So if you have any questions, any queries, you can always contact one person of our team. And then, as I mentioned before, we have our online tools, which will give you a good idea already. Should you need some further guidance or assistance, of course, our consultancy services are at your service. We have the Trozwell Strength of Glass Calculator, which is a structural calculation tool. We have Trozwell Win SLT, which is a light and energy transmission tool. Trozwell Glass Global is another structural calculation tool. And then we have the SoundLab app, which I described before. Then also, I just want to encourage you to subscribe to our laminated glass newsletter. And if you go to our website with www.trozifol.com, click on the laminated glass news icon, and you will get once a month or once every 2 months an edition of our laminated glass news, which describes mainly recent projects and how our PVB and other films have been used. We do have other specialist presentations, webinars, which are continuing to go on. Please go to our website and inform yourself about what is going on still in the next coming months. We have a designing with structural laminated interlayers presentation. We have a marine application, which Sandro will do in the coming days. I'm not sure about the date. He can tell you at the end of the presentation. We have a UV control presentation, which has already been done, but will be done again. And then we have also a presentation overhead glazing and balustrade presentation. Just a few words on Trozwell Clarity. As I mentioned before, our PVB is the most clear PVB you can find on the market. If you can see on the right-hand side, the comparison between our ultra clear PVB, the regular Trozifol clear PVB, and Centriglass. If you would compare this to our competitive products, then you would see that our products in general are much lower in yellow index than the other products on the market. Structural and security, we're not going to handle this in this presentation. There's a different presentation for that one, but we do have structural PVB films. Centriglass, of course, is a structural interlayer, which is used in hurricane glazing and other extreme applications. So it is safer choice to monolithic tempered glass or heat strengthened glass. We do have a load of stiff products. We have a normal PVB. We have Centriglass in different levels of UV, translucent white Centriglass. These are just some examples of structural glazing. This went a bit too fast. As you can see, stairs are a typical application for structural interlayers, the skywalks all around the world, balustrades and railings. And on top of the rock is a project in New York where there is a glass railing 3 meters high, which is protecting you from the elements. As I mentioned before, this is a tool for structural calculations you can find on our website. So we do have interlayers that can be used in blast and ballistic resistance and in anti-intrusion. We do have decorative films, colors, and the black and white total opaque PVB. So the colors and the tints, these are the colors we offer, different range of colors and different tints, which is mainly, the tints are mainly the bronze, the browns, the grays, and the translucent white, the typical glass laminating colors in the past. And then on the left-hand side, we have some specific colors. Then the Trozifol black and white, just want to highlight it briefly. It's 100% opaque black and 100% opaque white, with a high reflectance on the white, and it really looks extremely brilliant, and it's a very nice product. As I mentioned before, UV control, we have Extra Protect, which is blocking 100% of the UV radiation in the total UV range, and we do have Trozifol Natural UV and Centriglass Natural UV, which is letting through the UV light and is typically used in botanical gardens and greenhouses. Then we do have 100% green product, which is 100% recycled PVB, Beauticide G, should you be interested in a 100% green option. I think this is the end of the presentation. So thank you for tuning in this presentation. I hope it was a bit useful to you. Should you want a copy of this presentation, as Sandro mentioned before, please drop an email to Sandro or myself, or in the comments, and then you will get a copy of this presentation. So I hand it back over to Sandro now. Maybe just quickly, Sandro, your seminar on marine is on which date? Because I didn't quite remember anymore.
No, this is going to be Friday, the 16th of October at 10 o'clock. So let me say thank you, Jan, for your very interesting presentation. I hope everybody enjoyed this presentation, and I thank you very much. And whatever you need in terms of information requirements, drop us an email, both of us, so we can answer. We are very welcome to answer to you. And I hope see you in the next webinars. Thanks again, and have a good day. Bye, everybody.